All right, so here's the inverse portion of the retake review practice. This is also going to include practice if you want to fix your chapter 5 as well. So I really encourage you guys to do this. So finding the inverse, the first step of all inverses is switch x and y. If you see some problems like down at the bottom, g of x or 8 with f of x, remember those are just y. So the first thing I'm going to do is switch x and y. And inverse means we will be looping, but you can't loop until it's just the log or just the base and the exponent. So if you need to do any moving first, be sure to do that, just like in the solving. So this is just the log base 3 of negative 2x. Whoops, I didn't switch that. I'm ready to loop it. So it's going to go 3 to the x power equals this. It's looping into an exponent. And now to get y by itself, I need to divide by negative 2. And this answer is fine. Do not turn it into negative 1.5. Your base is 3. If the base is here is 3, then the base here needs to remain 3. So that's good. What would be better is to maybe bring that out as a fraction and write your answer like this. So this is the preferred answer. Okay? All right, second problem. So again, I want to loop it with the inverse. I'm going to first switch x and y around. And when I look at it, this is the log. The x plus 8 is not in parentheses. So I need to move, and I keep doing this, I need to move this negative 6 and the 8 over. So first I'm going to subtract 8. And then I'm going to divide by negative 6. And that's gone. So now I'm ready to loop. And it's going to go 3 to this crazy exponent equals y. So 3, and it's okay that all that's in the exponent. And that's the answer for number 2. All right, number 3, I'm going to first switch x and y. This is ready to loop because the log base 5 is of all of this. So I'm going to loop 5 to the x power equals all of that. Now to get y by itself, first I'm going to subtract this 3. And then I'm going to divide by this 3. And again, it is fine to leave the answer just like this. There's a better way to write it, but this is fine. We won't go into that, not for this. All right, number 4. This is an exponent problem, so I will be looping it. First I'm going to switch x and y. And I can't loop it until it's just the base and the exponent, which it is. And it's an exponent, so I'll be looping it into a log. So it's going to go log 6 of x equals all of this. And now to get y by itself, I'm going to multiply by 5 and multiply this side by 5. So when I'm done, this is my looped inverse version. So there's the exponent version, there's the log version. All right, next one, exponent problem. Similar. So first switch x and y, and then I want to loop it, but I can't loop it until it's just the base of 6 in the exponent. So first I'm going to move the 4, multiply by 4, and now I'm ready to loop it. And sorry, I keep switching that. That should be a y. I'm switching x and y, but not changing it into y. So it goes log, now 6 of 4x equals y. And that one's done. All right, number 6. Okay, switching x and y around. And I will actually do this correct this time. All right, so again, this is my base in exponent. So I'm going to have to move the 7 and the negative 2. This time I'm going to get rid of the fraction. I'm going to multiply this by negative 2 and then this by negative 2. And now, before I can loop it again, base and exponent, I'm going to subtract the 7. And now I'm ready to loop it. So it's going to turn into a log. Go with the base, loop towards, but go to around the equal sign. Whoops. So I'm going to have this equals y. And again, this is a great way to write the answer. I am going to wrap this in parentheses so we realize that that's all part of the log. But log e, remember, is ln. And there's my answer for 6. All right, 7. Okay, so now we're back to the practice of retaking for chapter 5, and I'm still going to let that stand, so I really encourage you guys to continue with the problems. So g of x, that's y, and I'm going to switch x and y around, and my goal is to get this y by itself. There's no more logs, there's no more bases and exponents, just working backwards in the order of operations. So first I'm going to add 2. And now, I really don't like y being in the denominator, so I'm going to multiply this side by the denominator, and it cancels out. And then I'm going to multiply all of this, so I'm going to wrap it in parentheses, by the denominator. And so now what I have is y plus 2 times 2 plus x equals 4. Now to get y by itself, I have to move 2, and I have to move all of this. First I'm going to move all of this, I'm going to divide it. Keep it in parentheses, cancels out, keep it in parentheses. And now to get y by itself, to move that 2, I just subtract it. So subtract it here, it's gone, subtract it over here, and there's your answer. So when you're done, it's y equals, and this wasn't an easy one, there are easier ones, minus 2. All right, next problem. Again, I want to switch x and y. This is y. And I know there's an exponent, but this is not like the problems of the other ones. In the problems up here, the exponent is the variable. Here, the exponent's just normal size. So our goal is just to get x by itself. So first switch x and y around. And now my goal is to get that x by itself. So I have to move the -2, the 3, and the 5th power. So first I'm going to move -2. So x over -2 doesn't really matter where the negative goes. And now I'm going to get rid of the 5th power. To undo a 5th power, I 5th root. That cancels out this. I'm going to 5th root this side. So this is where I am now. I have the 5th root of all of this. I'm going to write it like this, -1/2 x. Just a different way to write x over -2. And then that equals y minus 3. And now to get y by itself, I'm just going to add 3. So add 3 here, it's gone, and then add 3. This is the way it would look. So I have the 5th root of my fraction. And then outside of the fraction, I am now adding 3. And I'm sorry this is so messy, but the paper moves, so one-handed. All right, let's go to the back. A few more, practicing how to find the inverse. So again, this is y. My goal is to get that x by itself. So switch them around. And I'm going to move the -2, the 3rd power, and the 3. First I'm going to add 3. Now I'm going to divide by -2. Okay, so that's canceled out. And now to get rid of the 3rd power, I cube root. And that means I cube root this whole thing. Make sure that that -2 is in there. So when we're done, the inverse is... And you know, just some things that you can notice. It doesn't always appear as simple as this, but if they're subtracting 3, the opposite is adding 3. If they're a 3rd power, we're 3rd rooting. If they're multiplying by -2, we're dividing by -2. And that kind of happens in the other ones. You just don't see it as often, you know, but with the way things clean up. But you can kind of get that idea. Okay? All right, last one for this section. Okay, switch. Remember, that's y. Switch them around, and I'm going to change this into a -1 x to the 5th power. And I have switched x and y around. Now to get this y by itself, got to move this, this, and this. First I'm going to add 2. Then I'm going to divide by -1. For this divided by -1, I'm just going to divide the -1 into this, and the -1 into this. And now to get rid of the 5th power, I 5th root, cancels out, 5th root. So when I'm done, I know this is messy, I will have the 5th root of -x minus 2 equals y. Okay? All right, so continuing on, 1b, so I was going through and I didn't double check my problems. I wanted you guys to tell me if the following 11 through 14 are inverses, and as it turns out, too many of them aren't. So I've changed the problems. If you just want to take a moment, copy them down. And I apologize, didn't mean to do that, but these will be a little bit easier to work with because I want you to see that they will be inverses. So to see if functions are inverses, you are supposed to take g and put it into f, and as you do that it will simplify down so you just get to x. And do the other way, take f and put it into g, and when you're done you get to x. And you have to get to x on both of them. So you can kind of get an idea if they're inverses. If this is a cube root, there's a cube. They're adding 3 here, we're subtracting 3. So, you know, there's a very good chance that these are inverses. So first I'm going to take g and put it into f. So all of this is going in right there. So the parentheses are still there, but in for x goes all of this. And then I still have the minus 3 and the cubed. And my goal is everything's going to cancel out, simplify down, so I'm just left with this x. So first, simplifying, you just follow the order of operations. I'm going to go in the parentheses, and I see that adding 3, this is not in the radical, and subtracting 3 cancel out. And what you need to do then from there is show me what's still left, because if you just cross everything off up here, I don't know what you crossed off first. And now the cube root and the cube will cancel out, so I just get to x. Now I'm going to do the other way. I'm going to take f and put it into g. So this time all of this is going in for that x. So the cube root will still be there. But instead of x, we'll go all of this. And then the plus 3. So if you notice how the cube and the cube root disappeared last in this one, they will disappear first here. So this cube and this cube root cancel each other out, so you're just left with x minus 3, and then the plus 3. And notice I'm not just crossing stuff off, I'm writing the next step down. And then when the 3's here went first, here they go last. So I get just to x. And since I get to just to x on both of them, these are inverses, so yes. Here's 13. I'm going to just let you take a look at this one. And very similar problem, but that's okay. So this is a cube root, subtracting 1, adding 1, but let's try it again. So again, the first time I'm going to take g and put it into f, so all of this is going into there. So again, this was replaced by all of this. There's still the minus 1 and the cubed. So again, I'm just simplifying order of operations, go in the parentheses. Those ones can go away first. And now the cube and the cube root will cancel each other out, and I just get to x. And now I'm going to take the other option and take f and put it into g. So all of this is going right in there. So in that cube root, instead of x, I'm going to have all of this. And again, the cube and cube root disappeared first here, or last. Now they're going to disappear first, so cube root and cube. And the ones went first, now they go last, and I get to x. Okay, so we're going to cancel 12 out. I won't give you anything quite that difficult. So we're now going to go to 14 and take a moment, write it down. Again, fifth root, fifth power, adding 3, subtracting 3, adding 1, subtracting 1. They're probably inverses. So first I'm going to start by taking g and putting it into f. So all of this is going to go right in there. So fifth root, instead of x, oh goodness, goes all of this. That's where x was, and now I still have the plus 3, and then I have the plus 1 outside. So first I want to clean up in the radicals. So the first thing that's going to go away are the 3's. And now the fifth root and the fifth power cancel out. And now the 1's cancel out, so I just get to x. So now what I'll do is I'll take f and put it into g, so all of this is going right in there. I'm going to use the space up here. So in for x goes the fifth root of x plus 3 plus 1. And then I still have the minus 1 that's there. And then all that's to the fifth power, and then the minus 3. So remember, the 1's went away first, or last here, they'll probably go away first here. So when I go into the parentheses, they cancel out. And then the fifth roots went away second, so there's only 3, it'll go second here. So fifth root, fifth power, cancel out. And where the 3's went away first, they go away last, and you get to just x. So again, sorry 1A, I did change those problems and we ended up crossing off 12.